My name is Lars, and I have a bit of an unusual job title, which is Chief Evangelist. I work at a company called G&D, that's a security tech company, and as part of my day job, I explain our product, I explain digital currencies, I explain digital payments to our customers and to the market. I'm very active on social media and so on, which is a little bit disconnected from my engineering background. And the engineering background is why I'm curating a few modules for the ISAQB. For example, the formal methods, which is about using mathematical methods to ensure the correctness of software. The formal methods curriculum at the ISAQB is a training curriculum for working architects in the software profession. It's showing you how to write correct software, or it's helping you to improve the quality of your software. And the way that we're doing this is by starting from the basics. So we look at what makes a good specification. How do you design your system that you can write a good specification? What kind of properties do you need to cover in your specification? For example, the software is not supposed to crash, or the software is supposed to do calculations correctly in a way that satisfies the requirements of your customer. After you've completed this training, you should have a few tools in your toolbox that allow you to improve the correctness of your software in order to get better results, in order to get better design and so on. So just in general to make you sleep easier at night, because you can be sure that your software is going to do the right thing. This training will introduce a few different formal methods. It will talk about what is a specification, what is first order logic, how can we write properties, how can we validate those properties. And there's going to be a whole range of different tools, of different complexities also. And hopefully a few of those will be also applicable to your day job. The interesting thing about the formal methods module is that formal methods really is an umbrella term. So we're really talking about many different tools that apply in different phases of software development or in software design, and also to multiple different professions within that ecosystem. It's not necessarily about validating each line of code individually, but it's also about making sure that the design or the modularization or the interfaces of the system are correct. So to that degree, you could even argue that there's a big overlap with the business side of things, because you need to understand what the business needs and you need to understand what's at stake, right? So you need to understand what happens if the software crashes. Maybe the plane will crash, maybe the car will go too fast because it's not displaying the right velocity and so on. So it's also about understanding what are the requirements, what are even the regulations in the field, what you need to ensure in your software, and then all the way going with the tools to the implementation. So after taking this course, you should be able to understand which tools apply at the right stage of the design. So I will readily admit that using formal methods will make your project more expensive in the short term, because it's additional things that you need to ensure while you're developing your software. However, formal methods will save you a lot of money in the long term, because the idea is that you're preventing bugs and defects from happening in the first place. So you're trying to stop those bugs or these defects before they become a problem. For example, if you're manufacturing a car that turns out to be defective, you have to stop the assembly line if you find out the problem, and that's very, very expensive. It's easier to spend the money beforehand and fix the problem before starting the assembly of the car, right? So the argument is, if you have some long-term requirements, if you have a long-term project where defects might cause a lot of problems later on, you want to invest that money now. You want to understand now how to prevent that from happening, because in each software project, no matter whether you're making a car or whether you're doing just a small app, it gets more expensive to fix bugs the later you fix them, right? So let's better invest the money now to prevent them from happening than to have a big problem later on. Yeah, I think it would be good. It would be better if we had better advertising of formal methods, because very often it's just perceived as very mathematical, theoretical, sometimes even not agile because who writes specifications anymore. But sometimes there's just a lot at stake and we need to fall back to these methods in order to get where we want to be. I think no 3-day training can make you an expert in everything, but it will give you the fundamental ideas. You will be able to see with a particular lens on some problems, and you will be able to decide, well, this is actually a domain where I need to dig deeper and where I need to apply formal methods, and maybe this is the domain where I don't need it because it's not as critical. And just based on that judgment, you can then make better decisions and improve the outcome for your business. I think AI and LLM have a big role to play in the application of formal methods because many of those tools are able to validate the results. So imagine you have to prove something and you know what to prove, and then you can just ask a tool to go wild. I mean, there's been such tools around for a long time, even before we called it LLMs, even when we still call it machine learning, for example. However, it's a little bit difficult to apply this to finding out the specification or discovering the specification, because writing the specification requires you to deeply understand what the domain is about and how to extract the requirements. Once you have that, you can use those tools to improve your velocity in order to write the proofs or in order to validate the specification faster. But the act of writing the specification, that's a deeply human endeavor, and you need to talk to the business about this. I believe that everyone who's working in a software profession, especially software architects, are interested in improving the quality of their software. I mean, who doesn't want that, right? And one of the big things is to understand that sometimes in order to improve the quality, our traditional methods are not good enough. So sometimes we need to reach for the bigger guns, which are, for example, formal methods. The training is designed to give you this overview when does it make sense to use it and how it can help your life in order to improve the quality of the software. But another important takeaway is also, when does it not make sense? When does it just not matter so much? So not only do we want to give you the tools, but we also want to give you the judgment about when to use those tools and which tools to use. So I believe that this is a training that might sound a little academic, but ultimately there's going to be something in for everyone in the software profession.